As explained in the previous lesson, that we had been assuming that our gain was independent of frequency. In reality, this situation applies over only a limited, though normally wide, band of frequencies. This is illustrated in the figure on your screen, which shows a sketch of the magnitude of the overall voltage gain of the common source amplifier versus frequency. We observe that the gain is almost constant over a wide frequency band called the midband. Here, the value of the midband gain AM corresponds to the overall voltage gain GV that we had derived earlier. You can also show this on the graph. Now notice that the gain falls off at signal frequencies below and above the midband. The gain fall off in the low frequency band is due to the fact that even though CC1, CC2 and CS are large capacitors, as the signal frequency is reduced, their impedances increase and they no longer behave as short circuits. On the other hand, the gain falls off in the high frequency band as a result of CGS and CGD, which though very small, their impedances at high frequencies decrease and thus can no longer be considered as open circuits. Our task is to find two frequencies, FH and FL. These are two 3 dB frequencies, and at these frequencies the gain drops by 3 dB. Once we derive the expressions for FH and FL, it gives us control over them. We find out which quantities we can alter, that is the physical quantities, to fix FH and FL as per our needs. Remember, the amplifier is to operate in the midband. Our design of amplifier is based on accommodating all the frequencies present in the input signal. These frequencies should fall in the midband so that the amplifier amplifies all of them uniformly. This is why the straight line in the gain is so important. If any of these frequencies falls in the high frequency or low frequency band, their amplitude is going to be distorted. Two more quantities need to be defined. First one is the bandwidth. This is the difference between FH and FL. The other one is the figure of merit for the amplifier, and it is called the gain bandwidth product. An amplifier design is possible to trade off gain for bandwidth. Now we focus our attention to deriving an expression for FH.